Every time you look up at the night sky, you're looking back in time. Light from the moon takes a second to reach you, from the sun, 8 minutes, from the nearest star system, over 4 years. But what if you could look back further? Not just years or centuries, but to the very beginning, to the first few moments after creation itself. For all of human history, that dawn was invisible, hidden behind 2 massive barriers. The first was a veil of dust. The universe, especially in its nurseries, is choked with vast swirling clouds of cosmic dust. Visible light, the kind our eyes see and the kind the Hubble Space Telescope was built to capture, can't get through it. We were like detectives in a foggy room, able to see the furniture but completely blind to what was happening inside. The second barrier was time itself. The universe is expanding, and as it expands, it stretches everything within it, including light. Light from the most ancient objects has been traveling for over 13 billion years. Over that immense journey, the fabric of space-time itself has stretched that light, shifting it from the visible spectrum into the deep, invisible infrared. The oldest books in the cosmic library were written in invisible ink. For decades, we stared into the darkness, knowing the story of our origins was out there, just beyond our sight. We built models and theories, elegant equations that described how the universe should have worked. They told us the first galaxies would be small, faint, and chaotic. They'd be babies, slowly gathering mass over billions of years. We had a blueprint for the cosmos, a story we told ourselves about how everything came to be. But on Christmas Day, 2021, that all changed. On that day, humanity launched a key, a $10 billion gold-plated infrared key designed to unlock that foggy room and read those stretched-out messages, the James Webb Space Telescope. Its mission was to peer through the dust and capture the faint red-shifted heat of the cosmic dawn. Its purpose was to confirm our blueprint, to show us the baby galaxies we knew had to be there. But in the faint, ancient light from the cosmic dark ages, Webb didn't find a baby. It found an object so massive and so surprisingly mature that according to our own rulebook for the universe, it presented a profound puzzle. And this object is forcing us to ask an exciting question. Was our understanding of the beginning of the universe incomplete? The story of this puzzling object begins with a single, unassuming clue, a little red dot. In the data streaming back from Webb's JADES program, the JWST Advanced Deep Extragalactic Survey, astronomers were sifting through images of what is essentially a deep drill into the fabric of the universe. They pointed the telescope's golden eye at a patch of sky for days on end, collecting every last photon. Most of what they found looked like fuzzy blobs or faint smudges, just as expected. But one object, designated JADES-Z14-0, stood out. It was a pinprick of crimson light. At first glance, it was easy to dismiss, but the color, that deep, insistent red, was a telltale sign. In cosmology, red means old. It means distant. It means the light from this object has traveled for an almost unimaginable amount of time to reach Webb's mirror. We were seeing it not as it is today, but as it was just 290 million years after the Big Bang. The universe was only 2% of its current age. It was, for all intents and purposes, an infant. This discovery alone would have been historic, but as astronomers looked closer, their excitement turned to a profound sense of confusion. The problem wasn't just its age, it was its size and brightness. This galaxy wasn't a tiny young baby galaxy as most models predicted. It was shockingly luminous and surprisingly large, spanning over 1,600 light-years across. The analysis of its light revealed something even more baffling.
This intense glow wasn't coming from a supermassive black hole devouring gas, which can sometimes make a small galaxy appear artificially bright. No, this light was coming from stars, lots of them. The data implies a stellar mass of several 100 million times the mass of our own sun. As one research lead stated, how can nature make such a bright, massive, and large galaxy in less than 300 million years? This is the cosmic puzzle. JWST-Z14-0 is the unexpected giant, a surprisingly large object found in a cosmic nursery where only newborns were expected. Its very existence doesn't just challenge a few details of our theories, it puts attention on the very foundation of modern cosmology, the model we call lambda CDM, forcing us to consider that our blueprint for the early universe might need some serious revisions. To understand why one galaxy is causing so much stir, you first need to understand the official story of the universe. It's a theory known as the lambda cold dark matter model, or lambda CDM. For decades, this has been our standard model of cosmology. It's not just a guess, it's a monumental achievement that accurately explains a huge range of observations, from the afterglow of the Big Bang to the large-scale structure of galaxies today. It's our cosmic blueprint, the assembly manual for reality. The LCDM model tells a very specific story about how galaxies form. It's a story of patience, of slow, hierarchical construction. Think of it like building a skyscraper, but instead of steel and concrete, the universe uses dark matter and hydrogen gas. According to the model, after the Big Bang, the universe was an almost perfectly smooth, hot, dense soup of particles. But almost is the key word. There were tiny quantum fluctuations. Gravity, the universe's master architect, went to work on these imperfections, pulling matter into the slightly denser regions. The first thing to clump together was cold dark matter, the CDM in lambda. This is a mysterious, invisible substance that makes up about 85% of all matter in the universe. These clumps of dark matter formed vast, invisible scaffolds of gravity called halos. Normal matter, hydrogen and helium gas, was then drawn into these dark matter halos. Inside them, the gas cooled and condensed, eventually becoming dense enough to ignite the first stars. These first halos were small, so they could only form small, dim, disorganized collections of stars, proto-galaxies. The LCDM model is very clear on this point. The first structures had to be small. Nature doesn't build skyscrapers overnight. It starts with bricks. The story then continues through a process called hierarchical merging. Over billions of years, these small proto-galaxies, each in their dark matter halos, would pull on each other, collide, and merge to form slightly larger galaxies. This new, bigger galaxy would then continue the process, attracting and absorbing its smaller neighbors. It's a cosmic food chain, a slow, patient process of galactic cannibalism. Under this model, a large, mature galaxy like our own Milky Way is the product of more than 13 billion years of this gradual assembly. The LCDM model was so successful that when astronomers planned the James Webb Space Telescope, its primary mission was seen as one of confirmation. Webb was built to finally see these faint, small, chaotic baby galaxies that our blueprints said must exist at the dawn of time. It was meant to provide the final, definitive evidence that our story of the universe was correct. Then Webb opened its golden eye, and the blueprint was put to the test. JWST-Z14-0 isn't a brick. It's more like a fully formed wall where there should only be a pile of sand. It's a surprisingly bright metropolis in an era when the universe was supposed to be building mud huts. Let's break down the evidence, piece by piece. Exhibit A is the galaxy's sheer luminosity. As confirmed by the JWST team, the amount of light pouring from JWST-Z14-0 implies a stellar mass of hundreds of millions of suns. According to standard LCDM timelines, it's a challenge to explain how this happens so quickly. Just 300 million years after the Big Bang, cosmic dark matter halos were expected to still be relatively small. It's a puzzle how they could have grown and merged into structures massive enough to collect this much gas and form this many stars this fast. It's like finding a 30-year-old human who was only 3 months old. It strains the fundamental timeline of development. Exhibit B is the galaxy's apparent maturity. Recent observations have potentially detected the chemical signature of oxygen within JWST-Z14-0. This is a profound, timeline-bending find. Oxygen was not created in the Big Bang, which produced only hydrogen, helium, and a trace of lithium. Every atom of oxygen, carbon, or iron was forged in the heart of a massive star and released only when that star died. To find oxygen in a galaxy means at least one generation of massive stars has already lived, died, and scattered its ashes. For that to have happened by just 3